Good afternoon, everyone. My name is Jen Reitz. I am with the University of Delaware, and my co-pilots today are Lori Spagnolo, also with the University of Delaware's Institute for Public Administration, and Mark Buchanan and Catherine Gooding, both with Marshall University. We are a part of, if I can get it to advance, sorry, there we go. We are a part of the Mid-Atlantic TAB, as Becca said, which is a collaboration of these four institutions to help serve Region 3 of the EPA. And TAB stands for Technical Assistance to Brownfields. And so we serve Pennsylvania, Maryland, Delaware, West Virginia, and District of Columbia, sorry. And the services that we provide fall into four buckets. We essentially are here to provide hands-on support to communities from soup to nuts, basically anyone looking, businesses, nonprofits, governments, looking to take those abandoned and neglected vacant properties in your community and turn them into community assets through community redevelopment. And so we do this in a variety of ways. Today's webinar is a perfect example. And so we do outreach like this on a regular basis throughout the year on different topics. We also will come into your community and do a Brownfields 101 or a Brownfields boot camp, as we like to call it, just to introduce the concept of brownfields to everyone and build consensus around those ideas. We also provide grant support, and this is on both ends of the grant. As an applicant, we will help you plan the project and identify the correct grants to support that project, help build the budget, as well as a narrative to go along with that and strengthen your application. We will review the drafts. Once you hopefully become a successful applicant, we will assist you in terms of providing kickoff opportunities, helping to find the correct environmental consultant to do the work that you have outlined in your tasks, and engage the community around the ideas that are built within your grant. We do also provide site-specific technical assistance. And so we have a number of design studios on our team. And so they are really helpful in terms of working with the community to help them visualize what that, a vacant, overgrown, dilapidated property could be in the future. Because, it's really difficult for some people to be able to visualize what that future could look like. And so they will come out and provide hands on the ground assistance in terms of helping to design what that future could be, and do it in a way that meets your community's existing goals, right? The idea is to turn this brownfield into an asset and into a catalyst to do what the community is already looking to do. The area-wide technical assistance is really kind of one of those first steps as well, looking into inventorying, identifying brownfields on the ground, and providing walkabouts with different community stakeholders, as well as program support with the state. And so that's TAB. I mean, but essentially the bottom line is that we'll meet you where you are and help you navigate the process from beginning to end. So as Becca said, this is the second part of a two-part series. We hope you joined us last week, but if not, we will kind of briefly review a few of the items that we introduced. We are looking at the 5 steps of brownfield redevelopment, and we addressed both planning and assessment phases last week. And then this week, we are looking at demolition, cleanup, and redevelopment. But again, just back to basics, and for those who weren't able to join us last week, a brownfield is a property whose reuse essentially is hindered by the fact that there is either perceived contamination or real contamination on that site. And so a lot of these sites were developed as part of our industrial era in the US. And so they're located near waterways or transportation, because that was the most advantageous place to be. And they actually are located, many are located in or very near area communities that became disadvantaged or had concentrations of poverty. And of course, that legacy of industrial pollutants poses health risks and contamination both in the environment as well as for the communities living nearby. And so brownfields redevelopment becomes a unique opportunity to actually reduce those past harms by remediating the contamination, but also building resilience for the future and looking ahead. And we can do this by incorporating greener practices into the redevelopment, as well as cleaner energy, and really building those communities and making them stronger through the redevelopment process. I think you're all on the call. We all know what's the right thing to do to make and it makes your grant application more competitive. So I'm going to jump into demolition, and then Lori's going to pick up with cleanup, and finally Mark and Catherine will do the redevelopment piece. So demolition. So building demolition, this was an astounding number to me. Building demolition accounts for more than 90% of the 600 million tons of construction-related waste that ends up in our landfills. And this is every year. This isn't a overtime. This is every year. 150 million almost of construction debris was sent to landfills in 2018, which means there is a significant amount that's being recycled, but there's still opportunities for more of that to be reused. Brownfield remediation, of course, requires the removal of large quantities of both building materials, structural materials, and site materials. It is mechanically removed typically and will end up in the landfill. And because some of it is contaminated, but maybe not all. But right now, a lot of times the whole site ends up in a landfill, or all of the debris goes there, regardless of the levels of contamination and/or viability. So what's the alternative? Deconstruction basically is the systematic disassembling of parts or whole of a structure in order to recover maximum economic and public good through reuse and recycling. And this is a definition that comes from the city of Pittsburgh. There are several of them, but basically the main parts are really that kind of systematic disassembling of the materials so that you can look at them individually and decide what can be reused and can expand its life cycle instead of landing up in the landfill. And the other part that I think is really helpful in this is that it doesn't have to be the entire building, right? We can just look at a parcel or look at what's on site and say, okay, maybe it's just the hardwood floors, maybe it's just the windows or the doors or specific structural items that can be reclaimed and reused. And we'll talk a little bit more about that in the next slide. But in general, deconstruction, really the benefits of it are we're reducing the waste that goes into the landfills, but we're also reducing the need and the demand for virgin materials. And so there's less woods and forests that need to be cut down to create new hardwood materials when we have hardwood that we can reuse or other types of that. It also, deconstruction, it is a labor-intensive process, and so it provides the opportunity to create jobs and become part of what's known as the circular economy, where we're really trying to use materials for as long as possible, but train people to actually participate in that part of the economy. It is an emerging industry, right? And so there are challenges that are there. And then when you're talking about brownfield deconstruction on top of regular construction, those challenges are, of course, a little more, creates additional hoops. So just real quick to go over the deconstruction process, and this comes from the EPA's website. It's a 4-step process that starts with looking at the inventory of materials that can be reused or recycled. Then we want to look at the local reuse partners and identify ways that those materials can be reused, and then of course implement that where is possible. So the tool that's shown on this page is what they call the Deconstruction Rapid Assessment Tool, and it was essentially developed for large-scale residential redevelopment. So essentially for cities that have have portions of large neighborhoods that are with vacant land that they want to remediate and deconstruct and redevelop. But it's a good tickler. It's kind of to look at and see the variety of materials that actually do have repurposing ability. For me, I would never have thought of roof shingles as something that could be recycled, but it does have a list of that, as well as kind of what the conditions of those materials are, and can just be kind of a starting point when you're looking at this. One of the again, when you're talking about materials, some of the things you might not think about, and this was produced by Marshall University for one of the developments that we'll look at a little later. But, the idea that sawdust is compostable, or textiles and other fabrics can actually go to be reused to grow mushrooms, which, in Pennsylvania is a big industry that we have. And of course, wood to furniture and different types of things there. So, but the partners, and this actually might, you can take your inventory, but it might actually also be useful to start looking at the reuse partners. And this website is really useful in terms of creating a directory. And so I don't know if you can see how well you can see the legend, but it's really talking about shows where there are networks of reuse and reconstruction entities, as well as deconstruction and salvage, handling and warehousing abilities. And so you can kind of look at where we are in Region 3 and see that they are, there are a number of entities that are dispersed throughout our region. Many of them, of course, are kind of surrounding the larger cities. But you can click on each of those dots and find somebody that might have a directory for other ones. And so as we move in, some of the ones that are listed there are actually directories of more local retailers or contractors who do this type of work. And so, again, Reuse Wood is a directory specifically for wood reuse, and that's a national directory. We also have the Build Reuse, which again is a national nonprofit national directory. But then the direct providers, there's Doors Unhinged is actually a national company that just does doors. They specialize in deconstructing commercial doors and commercial rated doors and rehabilitating them and then selling them. So, and the Community Forklift and Second Chance are I believe in the Baltimore area. So they are out there. But when you can't find one, sometimes you're in an area where a lot of bright minds get together and decide to create their own deconstruction economy. And so this is an example of the Appalachian Reuse Corridor Initiative. That is their mission is to rethink the material reuse market and use that as a catalyst for economic development within the Appalachian region. And so, it's all of these partners of Virginia, West Virginia, Ohio, Kentucky kind of collaborate together, a number of nonprofits to create essentially this economy of reusing materials. And the red star at the center, which is the Black Diamond facility in Westmoreland, West Virginia, is a brownfield that doesn't look much different than what it looks like in the picture right now, but the vision is for it to be remediated and redeveloped as a reuse warehouse. So kind of that central location for these materials to go, as somebody deconstructs, it can maybe perhaps donate or whatever, direct it to this warehouse, and then other people can come in and look at what's there and be able to reuse it in other projects. The other thing I do want to mention, we're just kind of probably where some of the most of the deconstruction work is being done currently. There's a lot of municipal pilot deconstruction projects. And so City of Baltimore actually ran a pilot. The pilot has ended at this point, but there's a really great video on YouTube. I'm not going to share it right now, but the link will be there in the slides when you get a copy of the slides, talking about kind of all aspects of that circular economy and how deconstruction fits into it. Pittsburgh is currently running a deconstruction pilot program, and it is focused on city-owned land. So they're land-banked vacant properties and partnering with local nonprofits and contractors to do deconstruction and reuse those materials and keep them out of the landfills. So with that, I think that was my last one. Yep. We can pause for questions, and then Lori is going to pick up with the cleanup.
Okay, well, we'll go ahead and get started with the cleanup. And some of you may be familiar with some kind of traditional methods, but what we're going to go through is some of the variety of techniques that can be used to remediate a site and how we can think about being resilient in that space. So with that, we're going to talk first about the concept of green remediation. You can hit that next slide, please. And there are a couple overarching principles, right, to keep in mind. First, you want to minimize the environmental impact and kind of reduce the footprint of the remediation techniques that you're using. And you also want to optimize resource use, whether that's water, energy, or other raw materials that you may be using. There is a standard for this, the American Society for Testing Materials, and it really outlines all the specifics that are involved in this standard, and you will have the link if you want to take a look at that when you do get the slides. So let's go into, well, first of all, adaptation versus mitigation. So there's kind of two components to resiliency, right? So the first is adaptation, and we can look at that slide. And that is really kind of using materials and resources that can withstand climate change, right? So whether that's organisms or plants that have a higher tolerance to a range of climates, or whether that means stabilizing the conditions yourself, whether it's temperature or something else, to really enhance the aspects of the cleanup. The next piece of it is mitigation. And that's where we really want to focus on reducing greenhouse gases and emissions that are exacerbating climate change, right? So here's where you look at energy efficiency, low emission vehicles and equipment, and use of renewable energy, okay? And so some techniques use kind of one approach, some use both. First, we'll look at some of the in situ or on-site techniques to clean up a site. And the first is bioremediation, right? And that is really the process of using microorganisms that are going to neutralize these contaminants and remove them from a polluted environment. So in this particular case, we're looking at adaptation, right? We want to use climate resilient microbial strains that may be able to break down contaminants and again withstand a larger range of climate circumstances. And then, like we were just talking about, you can manage that temperature to really optimize that microbial activity. Another process that is an on-site technique is called phytoremediation. And this is in particular one of my kind of favorite new technologies. It's not very new, but it just seems to have so much promise. And it's just fascinating to me. And this is the use of plants that uptake and accumulate different contaminants, which can then be sequestered or destroyed. For example, I've heard that things like ferns and mustard greens are really effective at uptaking heavy metals in the soil, right? So in terms of resiliency, you can use a species that, again, can withstand a wider range of climate conditions and also look to capture and store that excess carbon dioxide. So this is an example of an approach that combines adaptation as well as mitigation. The next technique we're going to look at, and this is perhaps more traditional, especially when it comes to petroleum contamination, soil vapor extraction, or sometimes called air sparging. And this is when you're pulling the VOCs or volatile organic compounds out of the soil using a system of wells and pumps, and then the vapors are treated and purified before they're released back into the atmosphere. So this is an example of mitigation. We're looking at using energy efficiency here, right, with all the vacuum pumps and optimizing the extraction process to really minimize the use of energy. And I'm sorry that cut off right there. We can fix that before we set the slides out. So on to, I think we're going ex situ now, offsite cleanup. And the first, again, kind of more traditional technique that you may see used a lot is excavation and treatment, or they call it dig and haul, right? This is essentially where you just dig up the contamination and you physically remove it from the site, and then it's treated somewhere to neutralize it. It could be incinerated or something else. So here is where you want to kind of mitigate your impacts using dust control measures and low emission transport. and even considering using landfills that can capture and utilize methane emissions. Next slide. We do have a couple other types of techniques. Thermal desorption. This is where the soils or sediments are heated until they vaporize, and then they're treated or they're collected to be treated somewhere else off-site. In terms of mitigating aspects of this type of cleanup, you can look at powering your desorption units with renewable energy, whether that's solar or wind, and potentially capture and reuse the heat that is generated during this process. Finally, we have chemical treatment, and this is really the use of chemicals to kind of neutralize, convert, remove the contaminants from reactions like oxidation, precipitation. And in terms of adaptation and mitigation, you can select chemicals that are less volatile and more stable under changing climate conditions. And you can use environmentally friendly chemical processes and reagents as well. This can really be in situ or ex situ. So finally, you may be thinking, well, how do we possibly choose between all these remedial techniques? Well, the EPA does have a set of spreadsheets. It's called CEFA, or Spreadsheets for Environmental Footprint Analyses. And it's a set of Excel workbooks, which actually calculates the carbon footprint associated with a cleanup, looking at 21 different metrics that evaluate aspects of materials and waste that are being used and generated, the use of water, energy, air, and land and ecosystems. It is a very complex system, but it's absolutely helpful and a great way to really be thinking about the impact of the type of cleanup you select. And a lot of you on the call may not be doing this yourself. You may be just, subbing this out to a consulting company, but you need to know to ask for it, right? We need to be able to ask the questions of, what type of impacts to the environment and the climate is the type of cleanup going to have that you're recommending. So I think it's important that we just put this out there and have that understanding that there are different ways to approach this, and there are different ways to look at the impact that a cleanup can have on the environment and the climate resilience in the future. And so with that, I believe that we are moving to redevelopment at this point. Oh, I think there's one more slide there. Nope, there you go. Perfect.
All right, thanks, Lori.
Sure.
I'm Mark Buchanan, and I work at the West Virginia Brownfields Assistance Center on Marshall University's campus here in Huntington. And I'm going to share some slides that we're going to kind of highlight the redevelopment and kind of look at redevelopment really as the opportunity to make some improvements over what was there initially, especially since the cleanup. The first slide that I've got here is the former ACF site in Huntington. That was American Car Foundry. Here, they used to build rail cars and parts for rail cars and paint rail cars. So it's a monster-sized site, around 75 acres altogether. It runs from the main strip from Huntington, 3rd Avenue, all the way over. In the distance there, what you're looking at is the river against the hillside over here. Nonetheless, that the city ended up with an assessment grant that took care of trying to find and plot where the pollution was. They recently did the demolition and the cleanup. So right now, the only thing at this site is this sawtooth building that's still standing. But there's a lot of great things that are planned for this site in the redevelopment side. There's going to be some advanced manufacturing sites put in. West Virginia American Water is going to put a couple of offices in, and there's going to be quite a bit of businesses and some other things, some commercial developments that go in. It's really going to make a big difference for this part of town. And really the anchor is another brownfield site over here in this left-hand corner. Marshall University just put a brand new baseball stadium in over here. That's going to, and it's pulling during the spring. A lot of folks in to see baseball games. In addition to that, there's a minor league team that plays there through the summer. So really good things coming through. Go ahead, next slide, please. But when it is an opportunity when sites get redeveloped, an opportunity to redevelop the project in a manner that positively contributes to creating a more climate change resilient community. You know, in our part of the world or the country, we're looking at severe rainstorms, increased in severity and frequency, higher temperatures, those kinds of things. And what we've done here is in this next set of slides, we've divided some stuff up here to green infrastructure. We want to have a talk about how we manage all that extra water in a greener fashion, I guess we'll say, to try to combat climate change. We're also going to chat about green building techniques. Green building techniques are, it's more or less, when we say green building techniques, we're talking about this umbrella. And under that umbrella of green building techniques is a variety of different methods. We're just going to chat about a few of them. And of course, we can't have this conversation without at least bringing up and chatting about renewable energy, and then also probably energy efficiency is a fair discussion as well, a fair topic. Next slide, please. Before we get going too far, I have to go back and I like to give context about how and why. I'm a former stormwater manager, and this stuff is always near and dear to my heart. So I apologize for those folks who are not familiar with this stuff, but this really does play a role. When you look about these problems that we're going to be having, you know, as far as excess water, urban, you know, flash flooding, all of these problems can be sort of attributed back to the urbanizing landscape. And when we talk about an urbanizing landscape, we're talking about an increase in impervious surfaces like roads, roofs, parking lots. All of those things shed water. We build buildings a lot different now than the way we used to do 150 years ago. Ultimately, we would end up, you know, capturing that water and then sending it off with little regard with where it was going or what it was doing. We've kind of changed that now. We've developed better ways to manage that water. In the lower part of the slide here, there's a graphic. And I like this graphic here because it's really simple. It's a really simple explanation. You have a natural ground cover here in this first graphic, and you have some volume of water that falls. 10% of that is going on a natural type of setting, is going to come off as just regular runoff. 25% will end up as shallow infiltration. And shallow infiltration is more or less, that's just the groundwater that's not overly deep that ends up going over to the local receiving streams and water bodies and kind of recharges those water bodies during the driest times of year, you know, August, September, even into October, at least in our neck of the woods. And then another 25% of that volume of precipitation ends up down in deep infiltration, like your aquifer. So, and then 40% is returned back to the atmosphere between transpiration from the trees and just basically evaporation. Together, they collectively call that evapotranspiration. But if you look at this right-hand side, and when we have this precipitation in an urbanized setting, where we're talking about 75 to 100% of impervious cover, more than half, 55%, is sent to the local receiving water body. Only 10% gets to infiltrate down into that upper layer of the soil, and only 5%, even less, going down into the aquifer. And what you see in a situation like this is, you know, it really does alter the hydrology of that particular area. You end up with streams that are extremely flashy. In other words, when we say a flashy stream, it jumps up fast and it falls back down fast after rainfall. You know, that's going to increase the likelihood of flash flooding and problems associated with that. You actually end up, the stream ends up down cutting, getting extremely steep. So a lot of problems associated that between pollution and just the physical setting of the stream itself. But you can also see that as far as the evapotranspiration, only 30% is brought back up into the atmosphere. So just, again, just some context. Other issues that we would attribute to urbanizing landscape is urban heat islands. And next slide, please. And an urban heat island occurs when cities replace natural land cover with dense concentrations of pavement, buildings, and other surfaces that absorb and retain heat. Then you end up with increased costs for energy, for air conditioning, higher levels of air pollution, and some heat-related illnesses. The graphic on the left-hand side is it's a very simple concept. The more rural communities, you're looking at temperatures running 7 to 8 degrees cooler in those more rural or suburban type settings as opposed to the more urbanized sections of town. Next slide, please. So when we're talking about runoff and stormwater and dealing with that, we're always going to have a conversation. And for years, when we talk about infrastructure, you're going to hear some folks talk about gray infrastructure. Gray infrastructure is a traditional stormwater infrastructure built, basically gutters, drains, pipes, and in some cases, even some retention ponds. When we speak about green infrastructure, it's sort of a broad type of topic. We're talking about a management approach where the water, we're trying to mimic the hydrologic cycle. We're trying to get as much of that water, instead of running it off in a pipe and then sending it off to discharge in a local receiving body of water, we're trying to get that water down into the ground. Something more close to what it should be, trying to copy nature. Now, on a brownfield site that you're redeveloping, that could be a problem. And I have a couple slides later on with the ones that I'm presenting here. That we ran into some issues when we were trying to do this on site here on campus. Next slide, please. So green infrastructure, again, another umbrella. And under that umbrella, we're talking about different practices that we use to manage stormwater, reduce heat stress, and mitigate other climate-related challenges. And this is not an all-inclusive list here. I'm sure I left more off than I've got on here, but these are the low-hanging fruit, we'll say. Green roofs, bioswales and rain gardens, permeable pavement, stormwater planters, harvesting rainwater, urban tree canopies and green space, and also green streets and parking lots. Next slide, please. So some of the benefits that we'll have with green infrastructure, obviously improved water quality, reduced municipal water use, an important one's groundwater recharge, mitigating flood risk. It's not going to, you can never really truly eliminate the risk of a flood. You can reduce your chances, but completely eliminating it's almost out of the question. Increased resilience to climate change impacts like heavier rainfalls, hotter temperatures, and higher storm surge for those coastal areas. Reduced air pollution and reducing air temperatures in developed areas. Next slide, please. First one off the bat, we'll go with rain gardens and bioswales. These have become pretty popular. I know in our part of the world, we're usually last to really get on board with a lot of stuff over in our neck of the woods, but nonetheless, it's become fairly common to see rain gardens. And I'm the guy, when we're on vacation, we stop and take pictures of stuff like this, and my wife just rolls her eyes. She can never see the attraction to me for this that I have for this kind of stuff. But nonetheless, it's a really basic concept. It's a hole in the ground where water is put, and it's to sit and percolate back down into the groundwater, preferably. Now, not always a perfect setup like that. A lot of times these things will require engineered soils, and almost always, at least if you have high clay content in the soils, you're always going to have some sort of under drain or some way to manage that standing water. Because if you don't, you could end up with a mosquito problem in an urban area, and it can be rough to handle, rough to manage. Bioswales, very similar to a rain garden as far as the design. We always talk about bioswales as a way to move water to a rain garden per se, but very similar construction type. Next slide, please. Permeable pavement, got a couple different examples on this slide right here. On the left-hand side, you see the gentleman holding his foot on a hose as the water sprays across the asphalt. And basically, you just have large aggregate that's included in the asphalt that allows for the water to perk down through. And then on the other side, we're looking at just concrete pavers. And that's something we used a lot of around campus to try to capture and allow the water to perk down. Both of these are going to require, I don't want to say extensive, but there's definitely maintenance that will have to be considered if these become options in a project. Because if you basically just put them in and leave them like they're going to be the answer to your prayer, you're looking to have problems, because eventually the fine silts and stuff will eventually fill up those pore spaces. And then there's definitely a level of maintenance that has to be considered with these. Next slide, please. Stormwater planters. Occasionally, when you have a project and you're wanting to capture and divert stormwater, you might not have the real estate to be able to to make a footprint for a rain garden or even a bioswale, or move it to another place. So this can capture it. It's almost like having a small miniature rain garden in a box. And this was a project that we did on campus on a building that was well over 200 years old, called Old Main. And you're limited on the impervious surface, your catchment area, because I think we were catching maybe just under 400 square feet. It was just a corner of the building, and it was experimental more than anything, but very effective. It looks nice. And sometimes the low-hanging fruit like that is the way to get the conversation started if you're looking at other potential projects like that. Next slide, please. Or put it right back down into the ground and mimic the natural hydrology of an area. Sometimes the best answer is trying to harvest that rainwater. And when you talk about a rainwater harvesting system, you can go from something as basic as a 55-gallon drum up against a building with a downspout going to it and an overflow, to some of this other stuff that's more elaborate, like in this picture on the left here, where you have an underground tank type cistern to capture water. And it got some, the picture down below that with the large green tanks, that's a fairly significant system as well. You're looking, that's probably close to almost 10,000 gallons of water, I'm guessing, being stored there. And none of this, at least in my experience, I've never been associated with a project where we harvest rainwater to actually as a potable source of water. The uses you're looking at for this type of diversion would be landscape irrigation, even flushing toilets if you get it plumbed properly and put pressure on it, washing equipment, washing vehicles, and in some cases even watering livestock. That's an option as well. One other thing I thought I'd at least bring up, this odd looking structure around the tank, that's sort of like a first flush that captures a lot of that excess stuff off of the roof that you might not want in your tank. So it really helps eliminate the maintenance on that as well. So again, you will have maintenance. Even with a diverter like that, you're still going to have the tank's going to have to be cleaned occasionally. All right, next slide, please. All right, and like I mentioned earlier, we were looking at a project back in 2016 or I don't know, 2016 or 17. I'm getting old, and the years are starting to run together, so I apologize. I know it was somewhere around 16 or 17, but the university had decided that they were going to build a baseball stadium right here where this white star is at. This is a brownfield site, which it really wasn't that big of a deal. I guess they were going to consolidate material and place the stadium over that consolidated material, where they were going to get rid of the highest hazardous containing material off-site. They were going to send it to a landfill, but the rest of the low-haz stuff was going to be basically consolidated under the baseball stadium where that white star is sitting at. I came into the picture on this when they decided we were going to put a parking lot in on the opposite side of this street right here. And as we worked with the engineers, it turns out they had some phase 2 work done. They delineated a plume of a chlorinated volatile organic compound. And all of a sudden, my idea of putting an inch of rainfall that we received on this parking lot was no longer an option for us. I could not, they weren't going to allow us to put that down and try to get it to perk down into the soil for fear of moving that plume of the chlorinated volatile compound that they had there. And I'm not sure how far down it was. It was just above, an impenetrable surface is what the engineer said. So it must have been maybe bedrock or something it was sitting on. But if we were going to put any stormwater down, we were going to actually make it mobile, and they did not want to do that. So we had to come up with another plan. Go ahead, next slide, please. And we ended up with a bioretention cell that they had planned on installing. And if you look at it closely, and I do apologize for this is actually the design that came across my desk when we were trying to handle the stormwater management side of things. But you can see that there's an impermeable layer of clay that was going to be put in to keep the water from perking down into the native soil. And with the plan that we would capture all of the rainwater, and it was going to go into the city's storm drains and then into the sewer system, with the thought being that at least we were going to give it some lag. We were going to slow that swath of water from going into the city system. We were going to slow it down. We had to get approval from the DEP, Everything became approved, and then they decided that they were going to move the baseball stadium about a half-mile away after we went through all this work, and they located at the other site that I mentioned earlier in the presentation, back over toward the river. So all is fine and well. We're getting ready to do a cleanup project on this site now. I believe in August. We got a cleanup grant to take care of it. Next slide, please. And going into the green building technique section now, another umbrella. When we talk about green building techniques, we could be talking about a variety of things, but all of them are the practice of creating healthier, more resource efficient models of construction, renovation, operation, maintenance, and demolition that aims to reduce air and water pollution, stormwater runoff, waste, and unhealthy indoor environments, and transform buildings into a sustainable part of the landscape. And under that umbrella of green building, we've got a variety of topics, from just simply preservation of green space, developing green roofs, energy and water efficiency measures, a concept called passive survivability. That's my favorite, rainwater harvesting system. And then prioritizing solar energy and other renewable forms whenever possible. And then using recycled, repurposed, or sustainable building materials, just like Jennifer mentioned earlier. Next slide, please. We're going to go over these green building techniques real quick. And this is a little bit extreme when we're talking about green. So I don't think Mr. Olmsted, when he designed Central Park, had anything in mind that it was going to look like this in, 100 years later. But nonetheless, thank God that he did. If you've ever been, it's a beautiful place to be, but it's definitely an oasis in a concrete jungle. But the benefits of green space are immense for reducing erosion, sedimentation to the receiving streams, improving habitat in those streams. So ultimately, you're improving water quality, and also provides that chance for the rainwater to perk into the ground and recharge that aquifer. And it's also going to help to moderate a lot of those higher temperatures, like we were talking about on those urban heat islands. It's going to help to moderate that. Next slide, please. Green roofs. I was always surprised at how much the green roof actually does reduce runoff. And in this case, they're telling us 65%. This is an EPA stat. Makes the roof surfaces 30 to 40% cooler and reduces the heat flux from the roof to the building by up to 72%. Long-lived as far as the practice goes, 40 years or more. And then there's some wildlife benefits as well. Got a small just diagram of the basic parts of a green roof. The picture in this slide here is from the construction in 2007 on the engineering building. There was a green roof there on the I think it's the third floor. And nonetheless, it's still there. It's doing well. It's planted with sedums. And there are some maintenance issues with this as well. When plants tend to die, you're basically going to have a very, very hardy plant that can withstand high temperatures during the summer and really cold temperatures during the winter. So next slide, please. While on the topic of underneath this umbrella of green building techniques, you have to mention energy and water efficiency measures. High performance windows, green insulation, efficient heating and cooling systems will make a huge difference as far as energy use, reducing that amount. We're reducing the amount of energy that's used in a building. Lighting efficiency, if possible, natural lighting is the way to go. LED lighting works as well. It's basically sips energy as opposed to the old time incandescent light bulbs. Water efficiency as well is important. Low flow bathroom fixtures, high efficiency appliances, and there's my favorite again, rainwater collection. In Charleston, it's the capital of West Virginia here. They recently did a remodel of the Civic Center, and aside from all of the improvements architecturally that were made on this building and how beautiful it is now overlooking the Elk River, the more important stuff, at least from our vantage point, is it uses together collectively 45% less water than it did prior to the remodel, and a reduction of 25% in energy costs. And on the other side, on the right-hand side of the slide, that's another picture of campus here. In 2016, the entire campus was converted over to LED lighting as part of an overall, just a large project that took probably 2 years to finish. And at the time, they were touting 20 to 50% savings for costs for energy. And I gleaned this information from the university's sustainability page. But in 2016, campus officials saw a reduction in usage of approximately 4 million kilowatt hours, saving an estimated $321,000. Just crazy numbers. And I haven't sat down to see if that's how accurate it is as far as the cost per kilowatt hour, but nonetheless, it's still impressive either way. Next slide, please. And there's rainwater harvesting again. This is a commercial system. And again, I'm going to go over the benefits real quick. Just reducing peak flow, reducing combined overflow events. In some cities, you have storm lines that do double duty. They get sewage, but they also get stormwater together. So when you combine that during the rainfall, you get a lot of what they call a combined sewer overflow into a receiving water body, and really is hard on the water quality. But also saves money on the water bill and saves energy as well. Next slide, please. And as far as if you have the option for when you redevelop a parcel, integrating alternative energy or renewables is a very, very wise decision. And we're fortunate enough in our neck of the woods here where we're at. Coalfield has a company called Solar Hollow that it seems like when they first came to this area, you would see a truck or two. I see them everywhere now, and it's a wonderful thing to see. But a lot of the benefits when we start talking about solar and alternatives, you're going to offset greenhouse gases, sulfur dioxide, nitrogen dioxide emissions, and the particulates as well. And in our area, the maintenance on a solar system is relatively low. In some of the more drier climates, dust and things can settle on the panels and cause some issues, but we get enough rain that we don't have to usually deal with that. Okay, next slide. Excuse me. Now, Jennifer mentioned some of the upcycling and repurposing and sustainable building materials and recycling. I wanted to include it in my section as well. There are a lot of things that are recyclable. Most of the time, it's just having the community have a will or wanting to make that commitment to see that it's done and they follow through to make sure that those things are recycled. But anywhere from different types of plastics and concrete, steel, asphalt, all of those things can be recycled. And just like Jennifer mentioned earlier too, it requires less energy than using the virgin materials. You're also going to reduce the amount of landfill waste at the volume that we send to be buried. You're going to reduce emissions, and ultimately we're conserving natural resources. On the bottom part of this slide, I went ahead and added in a few of the outlets, I guess we would say. I know in West Virginia here around the Huntington, Charleston area, we have a group of folks that run this. It's called Habitat for Humanity Restore. You won't find, at least in ours, you won't find like, steel I-beams or asphalt or anything like that. What you will find are used doors, paneling, and different types of molding. So you can find some really beautiful wood pieces in there that are deemed or need a second life, and it's good to see. A quick Google search, I found a couple of other places too. There's a company called Repurposed Materials. They claim a presence nationwide. However, when you get into their website and nose around a little bit, the nearest one to the Mid-Atlantic region is Ohio, and the rest of them are kind of scattered out across the Midwest. But nonetheless, that effort is there, the interest to collect those types of materials. And they do deal with some of that heavier stuff, like what you're seeing with the asphalt and steel, real, hardcore construction stuff. And then another company called Recycling, which popped up on the search as well, located out in Massachusetts. And again, that's out of our area, but still, there's a will, so there's a way, ultimately. Next slide, please. Passive survivability. Is a building's ability to maintain habitability without relying on external utility systems for power, fuel, water, or sewer services, as well as being able to withstand floods, severe weather, and temperature extremes. Ultimately, it's a collection of all those things that we've been talking about coming together to take care of those different building systems in a unit. Between harvesting rainwater, solar panels, it's almost, you could liken it to trying to live off the grid ultimately. But several things come into consideration when something like this is used. The orientation of the building as far as, does it face where the sun rises or the sun sets? So building orientation, thermal insulation, trying to take advantage of natural daylight and ventilation, positioning trees and other things like that in the landscape as far as providing shade for solar control. So, then potentially using green roofs, green parking areas, all of those things are fair game when we start talking about passive survivability. Next slide, please. And another slide that these are just kind of some ones that I added at the end just because I at least wanted to mention them. Going back to the whole discussion about the urban heat islands, some of the real basic stuff that could be done, not overly expensive as far as cost per square footage, but increasing vegetation and trees. Of course, you're going to have some maintenance issues in that, but you can it's not that hard to find some, what I would say, well-behaved trees that aren't invasive to pipes and things like that and sewer systems. Installing green or cool roofs and replacing normal pavement with cool pavement. And that's something that I haven't seen too much of myself, but it seems like a pretty basic concept. You can see in the picture here on the right, in the upper right, they're putting a solar reflective surfacing agent down on the asphalt coating to reflect the light to try to lower the temperature there. These lower pictures here, green parking lots, a lot of these utilize what's called a grass cell. And a grass cell is just a series of cubes that come together that offer like some tensile strength. And they'll have like a growing medium put in them. And then they'll be sitting on top of like a bed of rocks that have a lot of pore space. And you will actually grow grass on this and you will park cars here. And I know around here, I've seen these projects used where it's used for parking overflow from a parking lot. It would be nice to see them utilized more as the first choice instead of just as an overflow. But those grass cells actually protect the roots of the grasses and stuff from coming crushed from the weight of the vehicles. And plus, it's a great way to infiltrate a ton of water on, when you're dealing with the MS4 issues. Next slide, please. And another some more basic stuff here. Urban tree canopies can play a huge role in keeping an area cool, providing protection from the wind and sun, leading to energy savings by 30% for cooling and up to 50% for heating, and also reducing the effects of the urban heat island by 2 to 8 degrees. I'm not going to read through all of these, but some of probably the stuff that stands out is the absorption of carbon dioxide at 330 pounds of CO2 per tree per year, helping to offset the effects of climate change or reduce the chances, and reducing stormwater runoff too. You don't really think about trees as absorbing a lot, but when you think about the total surface area of a tree and that it has to be completely saturated before it starts shedding water, it's a good place to store water when you're looking at things from the perspective of managing stormwater. So definitely extremely useful. Well, that's my last slide. I'll be happy to take any questions if anybody has anything.
Thank you so much, Mark. I know we had a question a little bit earlier that I think Catherine was going to elaborate on. Just what are some ways to address gentrification concerns communities may have after a neighborhood brownfield is redeveloped?
Yeah, thank you, Becca. And I'm curious to hear if any of the other presenters have thoughts on this as well. I don't know that I have like a one answer, right? I think that this is a really complicated issue, and anyone who says, I have the answer to gentrification is probably fooling themselves. But I think, Becca, in the chat, you responded by talking about particularly community needs and community engagement. And I think that that is, at least from my perspective, at the crux of the issue, right? And I want to go back to the Black Diamond example that Jen brought up on her slides. So that is a property here in Huntington. Our partner, Marshall's partner, Coalfield Development, is working on that project. And that's a giant old factory that is right in the middle of a residential neighborhood. And so I know that that project, they have a monthly community advisory group that comes together, and they talk about progress on the project and also what the community wants to see out of it. Even and they've taken that input into their plan, even to the degree of like recognizing, oh, we're going to have a lot of big trucks coming in and out of the neighborhood to this factory. How can we minimize the impact of the trucks to the neighborhood? And so like routing their truck routes in a way that is minimizing that impact. So I think that the community engagement piece is really critical. I think, Becca, you mentioned zoning also. I think that zoning has a big role to play in addressing gentrification. And I was in a webinar this morning from the Reimagine Appalachia Coalition, and they were talking about community benefits agreements. And I think that community benefits agreements, I'm not an expert by any means, but I think that those are one potential way when you're dealing with a developer to ensure that the community is getting some protection and some benefit from the development. And so that can look like, you know, commitment to a certain, you know, if it's a housing development, commitment to a certain number of affordable or rent controlled apartments in that development. Or I mean, there's tons of flexibility in what a community benefits agreement can look like. So I think those are a couple of options, a couple of things that could play a role. I see Casey Taylor put something in the chat. I had a student do some research on community land trusts as one strategy to address gentrification. That's really interesting. Thank you, Casey. I'll take a look at that. But those are, I wanted to address that question because I think it's really critical, and it's one that I think about a lot. I don't, like I said, don't have a solid answer, but I'm curious if any of the other presenters or anybody else on the webinar has any more thoughts about that.
Yeah, I'm glad you mentioned community benefits agreements, Catherine. That's exactly what I was thinking of. And I don't really have much more to add except to say that we were recently discussing a project with a developer, and he was super excited about it. And, you know, just was talking about how nobody in town was going to recognize the place in 5 years. And I just thought, well, that's a way not to do it. So I think it's really, the community engagement piece is just super important. Yeah.